Welcome to the CDP lab. What we're going to do is we're going to pretend that we're in an environment where we just walked into the door, and quite frankly, that's pretty much what you guys have done. I know what's happening here in this infrastructure, but you guys don't. So what I'm going to do is I want to demonstrate how we can discover the nature of our infrastructure through the use of CDP. We're going to create a drawing that matches one-to-one to everything that we have in our confines of our CDP tables on each of our devices. So what I'm going to do is I'm going to recognize that I have a number of devices in this infrastructure. I don't really know what they are. Let's just pretend that we're going to use CDP to discover those, and then we'll hop to each of those independent devices and we will learn the nature of the interconnections that we have. So what we'll do is, in this instance, I'm going to start on Catalyst 1. And on Cat 1, what I'm going to do is I'm going to type the command, show CDP neighbor. But what I'm going to do is I'm going to go ahead and just do it on all of the devices. And notice right here I have my chat window set to where anything that I type in here is going to be sent to all of my sessions. So every session that I have in my topology should be able to receive the commands that I type here. Now what I'm going to do is I'm going to type show CDP neighbor. And I'm going to press enter. And it's going to give me information. Now what I want to do is I want to verify that this shows up on every device that I have in my infrastructure. Make sure that it's sent to everyone all the way across the board, and it did. So let's look at this. So on Cat 1, what I'm going to do is I'm going to draw a catalyst switch. I'm going to say Cat 1. Now what I see here is I see Cat 1 is connected to R4 using a local interface. So let's say I know I have R10 here, and I'm connected to R10, and I know I'm connected to R10 on my Ethernet 1.0 interface. I also see here that on R10 I'm connected to 0.0. So this interface right here is 0.0. Now this also tells me that I have connections to two other switches. So I have a connection to a switch called Cat 2, and I have connection to a switch called Cat 4. Now again, I see the nature of these connections. To Cat 4 I'm using 0.2, and I'm connected to 0.2 on the other end. So here's my local, here is the remote. And I also see that I'm connected to this idea of Cat 2. Now when I connect to Cat 2, what I see is it's got local 0.0, and I'm connected to the remote side 0.0. Now this is all the information that I see related to CDP, but that's not all that there is. Let's take a look at something. Before we finish this mapping, I thought that it would be important for us to analyze exactly what information is being exchanged. Because notice right here it tells me the nature, and I'm using a virtualization platform. So where it says platform, it would tell me on a live device that I'm connected to a particular type of unit. So what I'm going to do is I'm going to say show CDP, and I'm going to execute another command. I want to show CDP neighbors, and what I want to do is I'm going to execute another command here called the interface. So we said that here we were connected to 1.0. So we'll say neighbors, it's going to be Ethernet 1.0, and I'm going to execute the command detail. Now look at see what it tells me. Notice it's giving me my iOS, tells me what version that I'm operating on. Notice right here it tells me I'm using version 2 to communicate. So that's making direct reference to CDP version 2, like we talked about in the theory. Notice it tells me my operational duplex, and it also gives me the IP address on that device that I'm connected to. So all of this information is on R10. Here again is that address that we have. So when we start looking at how this is giving the information, we can see that this is all pretty pivotal information that we're learning. Now if we were running things like power in our environment, we could also see the things like the amount of power draw that would be taking place. And the other thing that I wanted to highlight here is these timers. Now remember, we talked about how we had the timers. Well, all I have to do is type show CDP, and it's going to give me the information about those timers. Now notice I told you by default my CDP packets that are going to be sent, my hello messages, are going to be sent every 60 seconds. Notice my hold down time is 180 seconds. That's that interval. So if I miss 3 of these, 60 times 3 is 180, then I'm going to assume that that information is no longer valid and I'm going to take it out of that table. Also notice it tells me that I'm sending CDP version 2 by default. I didn't do any configuration at all. Now, one of the things that we also want to highlight here is they also have the capability of turning off CDP. Now, what I can do is I go to config T, and what I can do is, let's see, what commands do we have? We have CDP, and when we go through, we have run. Now, CDP run is on by default. So if I come up here and I say do show run pipe include CDP, it's not going to tell me anything. Let's do another command here. Hopefully it doesn't crash the system. So show run all. Actually, let's see if I can do it this way. Show run all pipe include CDP. Notice all of the configurations here. Now these commands are hidden from us normally. And notice every one of these TLV values that I was talking about. I told you that the list that I gave you by no stretch of the imagination was a complete list. But if you ever want to know them, they're in the iOS. They're in the config file. So the show running all command exposes not necessarily every command, but it does expose us to a lot of the commands. Notice here, information that we're exchanging is location, server location, application. We have different connections. These are all going to be associated with different interfaces. So let's go through here and do this. Let's exercise the command show run all, and let's not use any pipes to do any filtering. So let's see, where do we run into our first set of CDP configurations? It should be under our interfaces. It's going to take a little while to get to them. But you can see all of the commands that we have here. Let me get down to an interface. Here they are. These are TLV location, TLV server dash location, TLV for the application, and we're going to have each of these for different interfaces. It's going to be the same configurations by default because CDP is on by default. Now, what happens if I want to turn CDP off? Well, if I come in and say config T, no CDP run, I just turn CDP off for the entire device. Do show CDP. CDP is not enabled. Now, show or do show CDP neighbors and hit enter, it's going to tell me the same thing. CDP is not enabled. Now the key thing here is if I go over to Cat2, because we know Cat2 is connected to Cat1 on Ethernet 00, and I do show CDP neighbor now, what we're going to see here is that we have Cat1 that we're learning. It's still telling me that I'm connected to Cat1. Let's take a look and see what happens to this. So I'm sitting at 86. So it's exceeded 60 seconds. So I've missed a timer. 79. See if it goes up to 120. Still refreshing. 60. 59. We've missed 2 timers. Notice how the hold down time is cooking down. So notice each of these. 175, 157. Let's watch it. 49, 48. When it gets down to just around 120, it should toggle and restart. Should dive back up. So 39. See what happens. Notice the timer here on Cat1 is still cooking down. 26. 25, 24. Sorry to drag you guys through this, but it's important for us to watch the behavior here because at first blush, we may think, and notice what happened here. It went to 121. The moment it got down, after about 60 seconds, we received that next hello, and my hold down time restarted to 180 and started cooking down. This one, however, has not received any new messages. Therefore, what's going to happen is actually going to expire from my table. Now notice we have no corresponding entry for Cat1. And that's because when we went to Cat1 and said we want to turn off CDP, we're no longer sending those hello messages. So we have to recognize the fact that it can take up to 180 seconds minimum for all of the entries to disappear on our configurations, so on our individual links. And again, it's going to depend on when you actually implement it. But again, keep in mind, these hold down times start at their maximum, so they're going to start from 180 and count down to 0 until actually they're removed from the table. Now, what I want to do is I want to go back to Cat 1 and turn CDP on. So let me grab my highlighter here, or my eraser, and go back to Cat 1, and let's turn it back on. So show CDP, not show, CDP run, and turn it back on. Do show CDP neighbors. Now here's the other drawback. Because the timers are set up to a minimum of 60 seconds, what we're going to have happen here is it could take up to 60 seconds or 1 minute before Cat 1 could discover its neighbor. And it may not even be 60 seconds, it could be 120 seconds. So, you know, sometimes when you're doing classes like this, it's very difficult because you don't know. You get kind of suspicious, wondering whether or not you actually got the configurations properly. Because, I mean, like I said, it may take upwards to 2 minutes for it to discover all of its neighbors. So here at least we have R10 that we're connected to. And again, when this gets down to about 120, it should toggle back up to 180. So again, all I'm trying to demonstrate here is the fact that it may take upwards to 120 seconds for these entries to start appearing in our table. So we should, see where, show CDP neighbors, 177. So it ultimately got down to about 120 when we received that new hello, and we brought everything up and we started connecting. So let's go ahead and discover the rest of our layer 2 topology. All right, so when we go in and we start looking at what's going on, we know we're on Cat 2, we're connected to Cat 1. So let's go in and see what we have here. We've already got the command. So we see Cat 2 is connected, and I'll go ahead and scroll this up a little bit. We see that Cat 2 is connected to Cat 5, and it's also connected to Cat 3. We see also that it's connected to R11. So if we draw those connections in, we know it's 1, 0. Here, we know we're connected to 0, 0. You guys can barely see it there. Let me go ahead and I'll refresh the command. Show CDP neighbors. There we go. So when we go through and we start looking at how this is architected, now we see that Cat 1 is connected to Cat 2, Cat 2 is connected to Cat 3, Cat 5, and we can also see the interfaces. Here it's going to be 0, 1, interface 0, 1 to Cat 3, 0, 1 to 0, 1, and on Cat 5 we see that it's going to be 0, 2 to 0, 2, same as the other devices. Now if I hop over to Cat 3 and repeat this entire process, again, you can see very quickly we can discover the nature of our layer 2 topology. So recognizing here Cat 3 is connected to a router, R12, via 1, 0, and it's connected to 0, 0. Cat 3 is also connected to Cat 2. We've already got that because we did the determination on Cat 2 towards Cat 3, but we see now we're also connected to Cat 6. And we're connected to Cat 6 on 0, 2 and 0, 2. All right, let's go in and let's take a path here because we know Cat 5 is in the middle. So let's see if there's any connections on there. We'll take a shortcut here just so that we can quickly get into this configuration. So right now on Cat 5, we see Cat 5 is connected to Cat 2, which we already knew. We can also see it's connected to Cat 4, and it's also connected to Cat 6. And we have a new one in here called Cat 8. So we've got a lot of Catalyst devices in this topology. So we have Cat 8, and we're connected on 0, 3 on both ends. We're connected to 4, and we're connected to 6. We see that our interfaces on 4 are 0, 0 on both sides, and 0, 1 on both sides for Cat 6. Well, let's cut down to Cat 8, and let's see what happens there. Well, we already got the show commands here. So we see that Cat 8 is connected to Cat 9, Cat 7, and Cat 5, also to R16. So we know we have R16 down here using 10 locally, and we're connected to 00. And we also know that we're connected to another device called Cat 7, and we're connected to Cat 9. Our interfaces, let's take 9. Local 01 to 01, so it's 01 to 01. To 7, it's 00 to 00. Now, ultimately what we would find if we follow this entire topology is that we have a mesh of devices where we're actually connected to routers and switches, R14, R15, R16, and R17. Actually, I've got this backwards, so it should be R13, R14, 15, 16. Actually, I only did them this way, so I had it right the first time. So again, all we see here is that every device has one router connected to it except for Cat 5. Cat 5 has no routers connected to it. We didn't see that when we went through and we did it. Now, what this does is this highlights the fact that we can use this tool for the purposes of making discovery. Now, I cannot overemphasize the importance as a consultant that you know what your layer 2 infrastructure looks like. Most companies try to maintain drawings. However, what ends up happening is the whole process normally falls apart after a few months. Unless you have a specific person that's in charge of infrastructure control management, or you have an application that's going to do that for you. Now, a lot of the operations that I do consulting with, and I did consulting with in the past, even though they would be considered medium-sized businesses, they had still put a minimum amount of investment in their infrastructure with regard to monitoring and control. So there was no real SNMP, there was no real monitoring stations and things along those lines. So keeping in mind that CDP is going to be a go-to tool, all I want to do right now is highlight the fact that we can make manipulations to it, and then we'll wrap up this video and we'll move into a conversation about LLDP. So, the last thing I want to illustrate here are our timers. And also, another thing I almost forgot. Notice here on Cat 1, I'm sorry, on Cat 8, let me grab my arrow here. Show CDP neighbors tells me that I have a connection to R16. Now, if I go over to R16, I can also use show CDP neighbor here, which I already have, and it tells me I'm connected via local interface 00 to remote interface 10. Now, with this understanding, it's important for me to recognize that I can actually disable CDP on an interface by interface basis. So if I come in here and say config T, and I say that I want to go to interface E00, and I say CDP enable, that turns it on. But what I can do to turn it off is I can say no CDP enable. And the no form of this command actually disables CDP just on this interface. Now here's an important element. I could have turned it off globally by using the no CDP run, and then I could go to an individual interface and I can turn it on by an interface by interface basis. And you're going to find from many security professionals that this is what they recommend, because CDP can be a danger because it communicates so much information that if a third-party attacker was able to actually sniff our CDP exchanges, then they could discover a significant amount about the nature of our layer 2 infrastructure, and even the layer 3 management interface in IPs and stuff that are being communicated through CDP. All right, now the last element of this is I'm going to wrap this particular part up. We're going to look at the timers. I'm going to close this video up, and then what we're going to do is we're going to look at some diagnostics as it's associated with CDP. All right, so let's finish this up and dive right into the next part of it. So when we go through and we look at how this is going to be working, I've turned it off. So let's go back over to, which one did I use? I did 16. 16 should be connected to Cat 8. So let's take a look at this. Show CDP neighbors and see if it's actually starting to cook out. Well, we're down to 93 seconds. So we know we've missed 2 hellos already. And we can see that this is constantly going to keep dropping and it's not going to reset. Now, while this is happening, what I also want to do is look at some of the other configurations that we can do. Everything is going to begin with the CDP command. Now, I can advertise version 2, but guess what? Version 2 is being advertised by default. We saw that with the show CDP command. Do show CDP. We're advertising version 2. Now, I could change that by using the no form of this. I can also control my hold down time that I'm going to be able to wait, and I can change my timer. But again, I do not recommend that you guys do this unless you're specifically instructed to do so in the context of your lab exam. Now, there's a reason that they pick 60 seconds for this process to operate. I wouldn't mess with it, and Cisco doesn't recommend that you mess with it. However, they may want you to know that you can. Here's another component that I want to make certain that we understand. If I come up and I say show CDP, and I use the TLV value, what we're going to see here is I can enable or disable these processes. They are enabled by default on each interface, but if I did not want to send APP information, application information, all I would have to do is come in here and use the no form of this command. So bear in mind, there's a lot of interaction and a lot of interface configuration, but there's also the global configurations where we're going to affect the timers that's going to be running on our individual devices themselves. I also highly recommend that if you make changes to one device with regard to CDP, you really should make changes to all of the other devices. Because if you make your hello timer too small or your hold down timer too small, you can run into instances where the system is going to start flushing the table because it hasn't received a hello message based on how it expects to be able to receive it. So let's take a look at some of the timers. So if we come in here and we say CDP, and I want to affect my timer. Notice here I have the capability of changing my rate in seconds down to something as low as 5. So if I say I want to send it every 5 seconds, by default, let's see what ends up happening. So the CDP timer is 5. So now let's go in and do show CDP. And what we're going to find here is notice I have 5 seconds, but it did not change the hold down time. So now what's going to end up happening is I'm going to send, or I'm going to expect to receive this several hellos before I actually bring the connection down. All I'm trying to illustrate here is it's not an automatic computation of 3 times the hello message. It's simply going to be the 3 times what the default would be. So if I wanted to change this to something else, I would end up having to go in and do CDP hold down time, and then I would specify a new hold down time, which could be 15 seconds. However, keep in mind, if you make a change on one side or one device, you really should change all of the devices that are adjacent to each other. And keep in mind, it's going to cascade. So if I tried the adjacency across these 2 particular links, and I did it on Cat 7 and Cat 8, then obviously I want to do Cat 9 because Cat 9 is connected to Cat 8. So we don't want to have any situations where we cause information to start flapping inside of our CDP tables. All right? Now, let's see, that's the configuration, the change. Let's take a look at some of the interface configuration. So interface F0 or E01. No, E10. CDP, enable, and TLV. So on the interface, we can't really manipulate the timers too much. We don't have any real individual controls. So everything is going to be done in the confines of the global configuration. All right. So what we're going to do now is I'm going to, in this particular portion of the presentation, and then what I want to do is I want to take a look at some of the diagnostics with regard to taking a look at a specific output with regard to the CDP messages that are being exchanged between your devices, so you guys will know exactly what it's going to look like should you be posed with a diagnostics question that's going to be related to CDP. I'll see you guys in the next video. Bye-bye.